So let's talk about it a little bit. So here was the function you were told originally that this complex number right here is a root. You were supposed to run that through first. When you run that root through, you should be getting complex numbers down here at the bottom, certainly. But also, what's the most important thing you should get at the end? A zero, right? If you're not getting these numbers at the bottom, then you're not going to get zero at the end. Okay. So if you were struggling with some of the calculations, one of the things you might want to check out is, oops, I'm probably my keyboard. There are complex number calculators on the web. So Google search for complex number calculator. Symbolab comes up first. Sure, why not? So the first calculation you would one of the ones you would have had to do was -1 minus 3i and times that -17 minus 9i. And then it does the calculation for you, that -10 plus 60i, which notice was right here. So if you're having trouble with the computations, you can always go to a computational tool and do those. Now, as far as the answers go, these are the numbers that I wanted you to type in right here, those ones that are in the bottom row. Okay. Now, since we know -1 minus 3i is a root, what else has to be a root? Yeah, the -1 plus 3i. So using these as your coefficients now, without the zero, you wanted to run the -1 plus 3i through. Now remember, once you take a complex zero and its conjugate, what has to happen down here? Are you allowed to have any i's down here? No. Okay, so all of those numbers should have been real numbers. In fact, in this case, should have been integers. So this first part that I circled should have been the answer to the first part, and then this one should have been the answer to the second part here. Those numbers. We started with a 5th degree polynomial. When we do put 1 0 through, this becomes 4th degree. So now this is 3rd degree, right? So these are the coefficients for a 3rd degree polynomial. 3x cubed minus 20x squared plus 24x minus 8. Notice that your constant term is now much smaller. That was why I wanted you to do the rational roots here. So you didn't have to write as many roots out, right? So you need factors of 8 over factors of 3, and so you just get that list of 8. So this was the answer to the third part. Now again, from that list, we need to figure out which one we need. So graph it, right? Done that before, correct? Graph that polynomial that we just came up with. It's kind of hard to see on here, but on Desmos, if you put it in Desmos, it's this number here that you can see is about 2/3. That one's 0.66667 when it comes up if you put it in Desmos. So 2/3 is the one that you want to use. And so you run 2/3 through that last list of coefficients, and you really do get 0 at the end here. And so the 2/3 is the answer to the next part. All right, so that was the 4th part. 5th part, I think it was, well, whichever part it was. The 2/3 was the answer to the rational root. Remember, rational root is a fraction, right? So it needs to be a fraction of some sort or a whole number. Shouldn't have square roots in it, shouldn't have i's in it at all. And then the other 2 roots you can find using your quadratic formula, using the 3x squared minus 18x plus 12, or if you wanted to factor out a 3 first, you could do that too, and you run it through the quadratic formula either or. But you should get, if you simplify, the 3 plus or minus root 5. So that would have been, you should have written them separately with the commas, but since there's plus or minus in there. But that was the answer to the last part. Okay. Since there were so many struggles, here's what I'm going to do. A, this is posted on Moodle now, the solution. B, I posted a second quiz. Okay? What I will do, if you want, you don't have to. You can take your grade on the first one. However, if you would like to improve your grade, you can do the second one. Okay? I'll take the highest of the 2, the higher of the 2. By tomorrow night at midnight. I did an hour time limit this time instead of 45 minutes. Okay? Yeah. So that helps a little bit, get an extra 15 minutes. So anyway, that's what I'm going to do. So I'll take the higher of the two. All right. So you can go back through it again. This is posted. Exact same questions, just different function. Okay. So you'll notice it looks exactly the same, just with a different starting function. But if you want to, you can follow this as a guide. I encourage you to use a complex number calculator for the multiplication, so you don't have to take the time to type them or write them all out by hand. Does that sound fair? Yeah.
Thank you.
Yeah. Oh, you're welcome. All right. Other questions at all before we go back into rational function stuff? All right. Well, let's go talk about rational functions then. All right, so last time, remember we defined what a rational function is. What has to be in the numerator and the denominator of a rational function? What type of functions are on top and on bottom? Polynomials, good. Yeah, polynomials on top and bottom. So that's what a rational function is. It's a ratio of polynomials. Pardon me. We talked about finding vertical asymptotes, talked about finding horizontal asymptotes, pardon me. And we noticed that going through, we can start looking at the ratio of the leading terms to help us figure out if there was a horizontal asymptote or not, right? Right? Okay. So let's see if we can summarize that here in this next page. So we didn't get to the summary statement. So let's talk about that. We'll talk about another special type of asymptote that happens in exactly one case. And then we'll start trying to draw some pictures, get some graphs of these things, at least some rough sketches. Okay? All right, so I've written this generally as a polynomial on top, a polynomial on bottom, purposefully changed the letter here for your degree of the top and the degree of the bottom because they may not be the same, right? I wouldn't want to use an N for both of them. Okay. So what do we look for vertical asymptotes? What tells us about vertical asymptotes? What do we look for? Yeah.
Is it the higher power over?
That's for horizontal. I think you're thinking about the horizontal. Yep. What about vertical? Good. It's the denominator, right? What can't do the what makes vertical asymptotes typically? What? 0 in the denominator, right? Now remember, we did have the one example where we had some canceling going on, right? So as vertical asymptotes at the x values, that makes the denominator 0, but not the numerator. If it makes the numerator and denominator 0 at the same time, you have to do some more investigation, right? You would need to factor the top, factor the bottom, put it in lowest terms, and then see if you still have a 0 at the bottom or not. So x values where the denominator is 0 and the numerator is not, okay? Tells you where you've got vertical asymptotes. So again, remember that basically your vertical asymptotes and your domain go hand in hand, right? We've already talked about how to look at when the denominator is equal to 0 to figure out domain issues. It's literally the same type of problem, right? You'll set the denominator equal to 0 to look for asymptotes. You just need to make sure that there's not any common factor in top and bottom that needs to be canceled out. Because remember, in those cases, if they completely cancel out, you get a hole in the graph rather than an asymptote. We saw an example of that. All right. For horizontal asymptote, this is what Tatum was saying just a second ago. For horizontal asymptote, we look at that the highest degree term on top and on bottom, right? So what happens if the degree of the top, the n, is less than the m. So let's see if we can scroll back to an example where that happened. Let me go back to the previous page here. Degree of the top is less than the degree of the bottom. What happened for your horizontal asymptote? Yeah, it became 0, right? The y equals 0. And the reason for that was, again, look at your leading term in the numerator, look at your leading term in the denominator, and see if there's any canceling you can do, right? In that particular example that I have up on the screen right now, we had an x over x squared. That would simplify to 1 over x. So as x gets really, really big, 1 over x gets really, really small. Right? There we go. How a horizontal asymptote of y equal to 0. So if your n is less than the m, so this is degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. Oops. If the degree of the numerator is greater than the degree of the denominator, then what happened? Let's scroll back up again, see if we can find an example of that, where the degree of the top was bigger than the degree of the bottom. That was the middle example on the previous page, right? Again, in this case, we had x cubed essentially over x. That simplifies to what? You had x cubed over x. That simplifies to x squared. Does that have a horizontal asymptote? No. So there is no horizontal asymptote right here. So going back to my other page here, if the degree of the top is greater than the degree of the bottom, then there is no horizontal asymptote. Well, what case is left? I've done when it's smaller on top. I've done when it's bigger on top. What's the last case? When they're the same. Good. If the degrees are equal, again, one more time, let me scroll back up previous page. Notice in that example, we had 2x squared over x squared for our leading terms. That simplified to 2, right? And that was our horizontal asymptote. Okay? So when they're equal, you do the ratio of the leading coefficients. I'll write it as m and n again, just because it's what you have at the top of the page. But remember, we're in the case where they're the same, right? So bn and an would be the same, or an and bn would be the numbers. So the ratio of the leading coefficients is the horizontal asymptote. And we'll do some examples finding these things, but this is the summary, right? Degree of the top is less, y equals 0. Degree of the top is bigger, there isn't one. Degrees are the same, look at the leading coefficients ratio. And again, this all just ties back to in behavior of polynomials, essentially. All right. There is a special case. The special case, when you've got the degree of the top is exactly one more than the degree of the bottom. So think about if you had like x cubed over x squared, that would simplify to just an x, right? Which is still a line, isn't it? Not a horizontal line, but it's a line. In that case, we get what's referred to as a slant or an oblique asymptote. Okay, so this is a special case. When the degree of the top is one more than the degree of the bottom, you get to what's referred to as an oblique asymptote or a slant asymptote. Those words mean the same thing. In terms of asymptotes, they mean the same thing. We find these using polynomial long division. So to find slant asymptotes or to find oblique asymptotes, we do the long division to get them. Okay. All right. So let's look at this example. We're going to divide 4x squared minus 5x minus 6 by x minus 1. And now this looks a lot like problems that we've had before, right? You could also do this with synthetic division, but other ones we won't be able to use with synthetic division, so I'll just always write out the long division this way. What do we need to multiply x by to get 4x squared? 4x. Run that through. What are we going to subtract off? Good. So subtract off 4x squared minus the 4x when we multiply the 4x through. What do you get when you subtract? It'll be a negative 1x and then bring down the minus 6. Because we had minus 5 minus a minus 4, right? What do we need to multiply x by to get negative x? Negative 1. This last part we don't really need to worry about too much. I'll write it down anyway just to finish it off. Negative 6 minus 1 will give me negative 7, right? And that's how we know we're done, correct? The degree of what we're left with is less than the degree of what we started with when we divided by, I should say. So remember that the way we can write this now, and you just did this on your test, right? It's quotient plus, I'll write it as a plus remainder over what you divided by, right? That's how we wrote it. Okay, all right. Let's look at this for a second. And just in particular, look at this last bit. What's the degree, just looking at this last bit, what's the degree of the top? 0. What's the degree of the bottom? 1, right? So the degree of the top is less than the degree of the bottom. So as x gets really, really big, this is going to get really, really small. It's going to go to 0, right? So the only thing that's left is that piece, right? Essentially. Right? So it's this part right here that's your oblique asymptote or your slant asymptote. So this part is the slant asymptote. Since its asymptotes are lines, they're described by equations again. So we would write it as y equals 4x minus 1. And in particular, it's just the quotient part, right? It's the 4x minus 1 that we found for the quotient. So in general, you don't need to write this part. You just need to really figure out what the quotient is. I only wrote that part so we could talk about that 7 over x minus 1 getting really, really small as x gets big. Okay? But this is the process that you use to figure out your slant asymptote. Okay. All right. So let's see if we can put all of this stuff together and get a decent looking graph for different rational functions. So in this one, we're looking at the function x squared minus 5x minus 6 over x squared minus 3x plus 2. And it's asking a whole bunch of different things. So notice the first two are basically asking you to find some points on the graph, right? Where does it cross the x-axis? Where does it cross the y-axis, right? The next one, vertical asymptotes. Next one, horizontal asymptotes, oblique asymptotes. So this one's asking, okay, what happens when we've got some domain issues? These two ask you what happens on the tails, and then we'll put all that information together and get a pretty decent looking graph here. Okay. All right, so one thing I would probably do first before trying to do anything else is factor your top and factor your bottom so that we can answer these questions a little bit more quickly. How does the top factor? Yeah, x minus 6 and x plus 1, good. And the denominator factors as? Okay, good. canceling? No. So there's not going to be any of those holes things that we talked about, right? There aren't any holes. Okay. We only get holes if we can cancel a common factor on top and bottom, right? All right. X-intercepts. How do you, for any function, doesn't matter what the function is, how do you find x-intercepts? What do you set equal to 0? The function, right? You do f of x equals 0, correct? That's how we find any x-intercepts. In this case, f of x is a fraction. When is a fraction equal to 0? How do you make a fraction equal to 0? When the top is 0, right? That's when a fraction is equal to 0, correct? This is why I said factor at first. Looking at the factored form, when's the top equal to 0? Negative 1 and 6, right? So to figure out the x-intercepts, again, we'll set the numerator equal to 0, the top equal to 0, and get negative 1 and 6. So your x-intercepts are negative 1, 0, and 6, 0. Say that again? So remember, when the bottom is equal to 0, what happens? What do you get? Can you put a 0 in the denominator? No, so that's not going to give you the x-intercepts. We're going to do that here in a second, but that's not for the x-intercepts. The x-intercepts we're only worried about when the top is equal to 0. Yeah. Okay. Is that okay so far? Okay. To find the y-intercept, what do you do? Put 0 in for x. That's probably easier to do in the original form, right? Because if I put 0 in for x, what do you get on top? And what do you get on bottom? 2, right? So we'll get negative 3, right? Okay. F of 0 is negative 6 over 2, which is negative 3. So your y-intercept is 0, negative 3. So far, so good? All right, so now vertical asymptotes. What do we look for vertical asymptotes? Yeah, when the bottom's 0, right? We're looking for those places where it's undefined. So in this one, we'll set the bottom equal to 0. What makes the bottom 0? Yeah, 2 and 1. Good. So we'll have x equal to 1 and x equal to 2 as our vertical asymptotes. Again, asymptotes are lines. Lines are described by equations, so don't just write a number. Vertical asymptote should be x equals number. Horizontal asymptote should be y equals something, right? Asymptotes are lines. Lines are described by equations, not numbers. All right. Before we answer the next two, can you have a horizontal asymptote and an oblique or a slant asymptote at the same time? No. You can only, if you have one, you can only have one of them, right? May not have either, but you can't have two. You can't have both, right? One's an asymptote that looks like this. One's an asymptote that looks like this, right? Okay. Which do we have either of these in this case? Well, what's the degree of the top? In the bottom? 2. So which case is it? Do we have a horizontal or an oblique? A horizontal, and what will the horizontal be in this case? 1, right? Okay, so horizontal asymptote, the degree of the top is equal to the degree of the bottom. So your horizontal asymptote is the ratio of the leading coefficients. Your leading coefficients here are 1 in both cases, right? So y equals 1 is your horizontal asymptote. And again, if it has a horizontal one, it can have an oblique. The oblique asymptote, again, is a very, very special case. Degree of the top has to be exactly 1 bigger than the degree of the bottom. That's when you get an oblique. Okay? All right, let's see if we can put all these pieces of information together. Got lots of information. We should get a fairly decent sketch of the graph here. We said that the graph crosses the x-axis at -1 and at 6. Of course, I didn't do a very good job with the vertical asymptote, so this would be really, really skinny. There's a vertical asymptote at 1 and a vertical asymptote at 2 and a horizontal asymptote at 1. So I'm putting all those, forget my y-intercept. The y-intercept was -3, right? Okay. All right. So got lots of information here. The points that are on the graph, we definitely have to draw the graph through. The asymptotes are more guiding lines, right? They're things that the graph is going to get close to, okay? So notice that we've really divided this up into 3 regions, right? So we've divided it, this one's going to be a little bit trickier. We'll talk about it here in a second. We've divided it as the region up to 1, a region 1 to 2, and then 2 and onward, right? Let's do the easier of the 2 to start with, and then we'll talk about the piece in the middle here in a second. Let's look over on this region here on the left. I'm going to erase what I just wrote. This region over here, okay? You basically have 2 choices. I have to get close to this line. Get rid of that. And I have to get close to this line. Right? I have to get close to both of those lines. So basically I have to go either this way or the other way. Am I going to go that way? Up? What tells you you're not going up? The points. Exactly. I have to go through the points, right? So this side must go this way. I have to go through the points, so I had to go down, not up. Okay. Let's do the rightmost one. Well, the piece in the middle is a little trickier. Like I said, we'll talk about it here in a second. Same idea over on the right. We either have to go this way or this way, right? Either has to go down or up. Which way is it going to go? It's going to go this way? Yeah, it has to go up because I have to go through that other point, right? I got to go that way because I got to get through this point here. The piece in the middle is a little bit tricky, but are we okay so far? I'm going to do more examples of this. This is not the only example we're going to do. But is this okay? All right. In the middle, it's a little trickier because we've got 4 different possibilities. And here's what I mean by that. I have to get close. We ignore the we ignore the horizontal asymptote because horizontal asymptote is what happens on the ends. And now, right now, we're in the middle. Okay? So I'm not worried about the horizontal asymptote here at all. There's 4 possibilities. Either I have a U shape upward, or I have a U shape downward, or I have a crisscross idea. Now we can get rid of the crisscrosses because what would happen if I crisscross? If I go top to bottom or bottom to top, what happens in the middle? It crosses the x-axis. Do we find an x-intercept there? No. So it either has to be a U shape up or a U shape down, one or the other. Okay? It can't do top to bottom or bottom to top. Because we would have found a place where it crossed the x-axis if it did. Okay? So, rather than just guessing, let's see how we can figure out a way to do that. If you pick the number in the middle, like 3 halves, go back up to the original. If I put 3 halves in for x, put 3 halves in right here, is that a positive or a negative number if I put in 3 halves here? Positive. That's going to be negative. Positive times negative is negative. Down here, if I put in 3 halves, I get negative, and that's positive. Negative times positive is negative. Negative over negative is positive, right? So is it U-shaped up or down? Up, because it's positive, right? So I don't exactly know where it is, but it has to go somewhere like this. Has to. Oh, I don't know if it's well the way up there or closer down. Yeah. I'd actually have to put in a number to figure out what. I'd actually put it in and get the value out, and that would give me a little bit better idea where it is. I just looking for the basic shape. Yep. Does that make sense? Like I said, this wasn't not necessarily the best example to start with because it's kind of weird what it looked like. But right. Questions on this one?
Why did you play in 0 2?
I just picked something in between 1 and 2 to help me if it was on the top or on the bottom, and I really did just look for whether it was positive. You could, as long as it was something in between the two values, doesn't matter. I think 3 halves was in between the two. But I can write in the middle of the two. No, there was nothing special about 3 halves. That's a good question. Other questions on that one? All right, let's do the next one. Again, same suggestion that I had for the previous one. Factor what you can. Do that first. Anything to factor on the top? No, but what about the bottom? Good. Do that first. Factor anything that you can. That's going to help you answer x-intercepts and vertical asymptotes. And also tell you whether or not if you've got a hole, right? If you reduce it to lowest terms, you might have a hole instead. All right. How about x-intercepts? What do you look for x-intercepts again when the numerator is in it? Yep. When the numerator is equal to 0. When does that happen? -2, right? Just set your numerator equal to 0. That tells you the x coordinate of your x-intercept. For y-intercept? Good. Yep. Set x equal to 0. Put a 0 in for x. What do you get when you put 0 in for x? Good. -2/3. And I wrote 3 on top because I said 3 when I was writing the top. So your y-intercept is 0, -2/3. Notice that's not anything different than we've done before, right? This is how you find x and y-intercepts for any function, right? Find intercepts, x-intercepts, set y equal to 0. Find y-intercept, set x equal to 0. Nothing special about being rational functions for that. What do we look for vertical asymptote? When the bottom's 0. When does that happen? Good. X is -3 and 1. So you've got 2 vertical asymptotes again. How about a horizontal asymptote? What do we look for horizontal and oblique asymptotes? What do you look at? The degrees, right? Degree of the top is 1. Degree of the bottom is 2. So what case do we have in this case? Horizontal of y equals 0, right? Good. So your degree of the top is less than the degree of the bottom. So y equals 0 is your horizontal asymptote. If it has a horizontal asymptote, does it have an oblique? No. Again, oblique is a very special case, right? Degree of the top has to be exactly 1 more than the degree of the bottom. Very special case. So far, so good. All right, finally sketch the graph. So we got lots of information again. We have got an x-intercept at -2. We've got a y-intercept at -2/3. Vertical asymptote, -3. and at 1. Is that the other one? Yep. And horizontal asymptote of your x-axis. I'll put the little dashes on here. I don't really need to put them on there since I already have the x-axis as a guiding line. Just putting it on there so that we're reminded that there's an asymptote there. Okay. In this case, let's do the middle first, because I think in the middle is a little bit easier. Again, you've got cases in the middle, right? It can either both go up, both go down, or crisscross, right? What's this one going to do? Yeah, it's going to do a crisscross kind of idea, right? It's either going to go top to bottom or bottom to top. And again, I got to go through these 2 points. So is it going to go top to bottom or bottom to top? Top to bottom. Good. So it has to go this way. Roughly. I missed the points too. But roughly, right? We're not going for perfect. We're just trying to use the pieces of information we have to get a rough sketch. So far, so good? Yes?
Why is there an asymptote there but it still crosses?
So the asymptote only talks about what happens on the edges. So you're allowed to, actually you can cross an asymptote infinitely many times. So we're only, the asymptote's only for horizontals, only worrying about the edges. In the middle, anything. It's a good question, I know. A lot of times you think, oh, I can't cross a horizontal asymptote, and that's false. I can't cross a vertical one because it's undefined there, but horizontal ones you can cross infinitely many times, actually. Is it okay so far? All right. For the other pieces, notice there's not a lot of help for points, right? I know that it either has to go up or down, right? In both cases, up or down, right? But I don't have any points over there to help me. So let's do a bit different analysis, just like we did last time. All right, so let's go back up to this factored form. I'm going to write it back down here so I don't have to keep scrolling back and forth. Just so I can refer to it here. Let's just choose some x value over here and see what we get out for a sign, either positive or negative. The reason is that if it goes up, it's always positive. If it goes down, it's always negative, right? So I just need to figure out if it's positive or negative at some point. Okay? So put in like -4. On top, it's going to be negative. On bottom, it'll be negative times negative. So we got negative over positive, which makes negative. So it must go downward this way. Pick a number on the right side. What number might you want to plug in on the right side? 2? 2 will work, okay? Put in 2. This is. So everything is positive, so the whole thing will be positive. So is it going to be going down or going up? Going downward in this case, right? So it'll go this way. That okay? And if you check this on a graphing utility, it should look a lot like this. Okay. Again, the edges may be in a different spot. It might be shifted a little bit, but it's the right general shape. All right, work on the next one for a minute, and then we'll chat about it. Ready to talk about it? Good. All right, for x-intercepts again, what do we look at? When the top equals 0, when does that happen? 5/2. So 5/2, 0. Yeah. I didn't worry about factoring because there wasn't a lot of factoring to do except for, what, a 2 out of the top if you wanted to, which didn't make a lot of difference, right? Nothing was going to cancel, right? You'd have 2x minus 5 on top and 2x plus 5 on bottom. Okay. How about the y-intercept? What'd you get for that? -2, right? Plug in 0 for x. You get -10/5. So 0, -2 for your y-intercept. Good for that? So far, so good? Yeah? Okay. Vertical asymptotes. And what did you do to find that? Good. Yep. Set the bottom equal to 0. So you get x equals -5/2 for your vertical asymptote. How about horizontal asymptote? Is there one? Yes. Why? Good. The degrees are the same, right? Top and bottom both have degree 1. They're the same, so there is a horizontal asymptote. What is it? 2. How'd you come up with 2? Good. The ratio of the leading coefficients in this case, since the degrees are the same, right? So if it has a horizontal, is there an oblique? No. Good. We okay with all that info? Yeah? All right, so let's put it all together. 5/2 was an x-intercept. Was it -2? I've already forgotten. Yeah, -2 was a y-intercept. Vertical asymptote at, vertical asymptote at -5/2. And horizontal asymptote at 2. This is a little bit easier because we just got it divided into 4 pieces, right? We really only have to do one side and then the other. All right, so again, asymptotes and points here are helping us guide the function, right? I gotta get close to this asymptote over here on the left. I have to get close to this asymptote and that one. So either I have to go up or go down. Which one is it? Up or down? Good. Yeah, if we're gonna go down, what would happen? It would cross, right? The x-axis, and we didn't find one, did we? Okay, so it has to go up. That's exactly right. We would have found an x-intercept if it went down. But we didn't. So it has to go up. On the other side again, it either goes down or up. Which way does it go? Up, because the points. I have to go through those 2 points, right? So it has to go up that way. Does that make sense? Questions on that one at all? Okay. I think the last example, I'll let you work on that one on your own for practice, but notice what's going to happen. What kind of an asymptote for the last part there, right before the last part, what kind of asymptote are you going to get that for that one? An oblique. And remember, to find your oblique, you have to use polynomial long division. Okay. All right, so your quiz, your kind of take 2 quiz, if you will open up in about 3 minutes. Okay. Again, just finish it by midnight tomorrow, right? I posted the solution to the quiz that you did for last night. Okay. So you can use that as a guide. I encourage you to go look for a complex number calculator here online if you're having issues with doing the complex number arithmetic quickly. Okay. Go look for that. It's the same exact quiz except I changed the function. So that's all I did was go in and change the function. Okay, so you can use the old one as a guide, the solution as a guide to help you, and I'll just take the higher of the 2 scores. Sound like a plan? All right. All right, you're welcome. Have a good one. We'll see you on Friday.